Hey all, today we're going to continue to discuss those important degree and radian measures from a couple of days ago, and we're also going to reintroduce the unit circle as well. So let's start with those two tables of important degree and radian measures. I'm going to just abbreviate D for degree measure and R for radian measure, if that's okay. So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So I would recommend pausing the video, copying this down in your notes, and see if you can recall what those key radian measures are. 0 degrees is naturally just going to be 0 radians. 90 degrees is pi over 2 radians. 180 degrees is pi radians. 270 degrees was, think about it this way, 270 degrees is 3 times 90, isn't it? So 270 in radians is going to be 3 times pi over 2, or just 3 pi over 2. 360 degrees, think about it this way, 360 degrees is twice 180 degrees. So the radian measure for 360 degrees would simply be twice of pi, or 2 pi, right? And there were a few more from our last lesson that I highly recommended you start getting familiar with, and that was 30 degrees, 45 degrees, and 60 degrees. So once again, I would probably just pause this video, jot it down in your notes, and see if you can fill in the radian measure before continuing with the video. So 30 degrees, think about it this way. 30 degrees is 180 degrees divided by 6, right? So if we know that 180 degrees is pi radians, we can just say that 30 degrees would be pi radians over 6, or simply 180 degrees over 6. 45 degrees would be pi radians, remember, which is 180 degrees divided by 4, right? 180 divided by 4 would get you that 45 degrees. Similarly, 60 degrees, well, that's really 180 degrees divided by 3, and 180 degrees is really pi radians. So our 60 degrees is pi over 3, right? So it really is of your benefit to try to start committing them to memory, throw them on some flashcards, get really familiar with them, okay? So now what we're going to do is we're going to take it over to another very important trigonometry topic for your pre-calculus year, and some of you calculus as well, and that's the unit circle. Okay. And we call this circle the unit circle for a reason. The radius is 1 unit. And the unit circle itself is drawn on the xy axis. Good enough. I don't really need this extra axis here. Continue that. So the origin is the center of the unit circle, and since the radius is 1 and we are on the xy axis, we should be able to figure out the coordinates of each of these points that I'm bolding. Okay. So if our radius is 1 and we go from the origin 1 over to the right, this would naturally be the point just simply 1, 0. And if we went up 1 from the origin, that would be the point 0, 1. This point over here would be negative 1, 0. And this would be 0, negative 1. Right? Now we're also going to be talking about some angle measures. So we consider the positive side of the x-axis the starting point when we read off of the unit circle. So considering that it's the starting point, we consider this to have a measure of 0 degrees or 0 radians. So I'm not going to put the degree symbol next to my 0 because I'm going to be labeling this unit circle actually in terms of radians. And when you travel along the unit circle, we typically go in a counterclockwise direction. So we go in this way. And since we know that there's 360 degrees in a circle, and at this point, which my arrow stopped is a quarter of the way, that would be equivalent to 90 degrees. And since we're going to emphasize labeling all of our degree measures in actual radian measures, I'm going to label this point right here the pi over 2 mark. Pi over 2 radians, which is 90 degrees, right? If we continue traveling, right, now we've gone a complete 180 degrees, right? And so we associate over here as being 180 degrees, right? But let's focus on the radians. So we're going to actually label it as pi radians. Okay. If we continue our travels around the unit circle, we've gone another 90 degrees. So we've gone 270 degrees, right? And 270 degrees is 90 degrees times 3. So if we know 90 degrees is pi over 2 radians, all we have to do is triple that. And finally, when we make it back to our start point, we've gone a total of 360 degrees around the unit circle. So we actually consider the starting point sort of the end point as well. And since we've gone 360 degrees around, that would be equivalent to 2 pi radians. So on the next screen, I'm going to, once again, draw the unit circle, but I'm going to draw it a little bit bigger, and I'm not going to label it with as much. I'm just going to draw a little bit of a bigger XY axis. Trying to draw these circles is not easy. Whoops. That could be better. Okay, good enough. Okay, so now what we're going to do is we are going to make a right triangle in quadrant 1. And how we're going to do that is we're going to start at the origin. And it doesn't actually matter where you make the hypotenuse of this right triangle. So it doesn't necessarily have to be like cutting the first quadrant in half or anything like that. But I'm just going to draw it arbitrarily like this. And then I'm going to indicate that point right there. And what I'm going to do is I'm going to drop a vertical line down, which is perpendicular to the x-axis. And make my right angle right there. And if you have a highlighter or a different color, or just simply bold it, just so that we can have our right triangle stand out from our unit circle itself. Okay. And what our task now is we're going to try to label all of these sides. With either something general or something specific. Actually, the only length that we know is the hypotenuse. And if I'm telling you that this does represent the diagram of the unit circle where the radius is 1, isn't the hypotenuse of this right triangle considered the radius of this circle? So we actually do know that the length of that side is 1. Now, I didn't tell you what the coordinates of this point is right here, right? I didn't tell you that. If I did tell you that, We actually could figure out the lengths of the horizontal and vertical side. For instance, I'm just making this up, but let's just say I told you that this point was like 0.8 comma 0.6, let's just say. If I did tell you that, then we would know that the length of the horizontal side would be 0.8, right? Because that's 0.8 units over to the right, and that the vertical side would have a measure of 0.6, right? Notice that I chose x and y values that were smaller than 1, right? Because the radius, at most, the radius is 1. So these lengths can, of course, extend past 1 unit. So I had to pick decimals like this. So our task is not actually to be so specific and be a little bit more general. So how about we just say that this point is xy? So we would know that the length of this horizontal side would just be x units, right? And we would know that the length of this vertical side would be y units. And let's give this angle here nearest the origin a name. And a very popular name that we call our angles in trigonometry is theta. Basically, you can make maybe like an O with sort of like this nice little hook to it. And out loud we say theta. It's a Greek symbol. Okay. And now that we have all 3 sides labeled, and we know that we have a right triangle, what we're going to do is we're going to do a little SOHCAHTOA. So let's start with the SO, which is the sine of theta, right? We should understand that sine theta is the opposite side over the hypotenuse. So if we actually put everything together here, based on our triangle, we would say that sine theta is equal to the opposite side, which is y, over the hypotenuse, which is 1. So if you take a look back and see what we just found, we actually figured out another way to say y when we're on the unit circle. The y value is really equivalent to the sine of theta. So look how I'm going to start to rewrite my coordinates of that unknown point. Now let's talk about the cosine. So the ka, so C, and we have our A and our H. So let's check out how this works out. So the cosine of theta would be the adjacent side of theta, which would be the x, over the hypotenuse, which is 1. And check it out, in a very similar way, we just figured out another way to represent the value of x on the unit circle. The value of x is really the same thing as saying cosine of theta. So I'm going to go back up here and fill this in, right? And if this is looking familiar, that's great, because we did do this earlier in the year. So this, we're going to put a nice heart around this. So we have developed a new way to write xy coordinates. We can write xy coordinates as cosine theta, sine theta, given the fact that we're on the unit circle. See, that's only true if you're working with the unit circle. It's not true for any case in which you're graphing triangle. We have to be working with the unit circle. And let's finish the SOHCAHTOA with the tangent. So this is the TOA in SOHCAHTOA. So tangent theta would be equal to the opposite side, which is y, over the adjacent side of our angle theta, which is x. And therefore, since we actually know another way to write y, and we know another way to write x, we can develop another formula for tangent, and that is sine over cosine. And this is something you also want to put a heart around. Okay. And again, that's specific, 4 questions related to the unit circle. So we're going to try to put everything together now. And we're going to make another unit circle. And we're going to go back to much of the labeling that we did earlier. So we're going to label the coordinates. So this right here is 1, 0. This right here is 0, 1, negative 1, 0, and 0, negative 1. Okay, we're also going to put our radian measures. I'm going to change over my color. So remember, the positive side of the x-axis is like your starting reference point. So we associate that as being the 0 radian mark. We're going in a counterclockwise direction. So this angle up here would be really 90 degrees, but again, we want to get really comfortable with radian measure. So 90 degrees is pi over 2 radians. And if we keep working our way counterclockwise, this would be where 180 degrees is, but we want to say that it's really pi radians. This right here is where 270 degrees would be, but we want to say that it's 3 times pi over 2. And finally, making our 360 degree rotation, we want to go back to our starting point and say that that's also equivalent to 360 degrees, but again, we're labeling it as 2 pi radians. Okay. Now, since we are on the unit circle, we do know that all points on the unit circle are expressed as cosine theta, sine theta. So, and notice also that that's alphabetical order. If you have trouble memorizing that, C comes before S. So what I do is, I'm also just going to label CS above each of these points, just to remind me. I can't get the S up there. Hold on. So we're going to practice some more. And I want you to try to figure out what the sine of 3 pi over 2 is. How about the cosine of pi? And then how about we do the tangent of pi over 2? Okay. So I would recommend pausing the video, see if you can figure it out, and then restart up the video to see what the final answers are going to look like. Okay. The more and more you draw the unit circle, the faster you'll memorize it. So instead of flashing back to the previous screen, let's just practice creating the unit circle again. Okay. This is our 0 and our 2 pi angle. This is pi over 2. This is pi, and this is 3 pi over 2 radians. And I give a little quick CS under all of my coordinates to remind me about the very special property on the unit circle. X coordinates are really cosine theta, and y coordinates are really sine theta. So getting back to the practice examples, the sine of 3 pi over 2. So I'm going to locate the 3 pi over 2 angle, which is right here. And the sine coordinate is really the sine of theta is really the y coordinate. So the sine of 3 pi over 2 is really this -1 value that we see. Cosine of pi. So I'm going to locate where the angle for pi radians is, which is right here. And the cosine value at pi radians is really the x coordinate. So that would be, once again, -1. Now tangent. So tangent is not directly visible on the unit circle. We have to understand that tangent has that very important conversion formula. The tangent of pi over 2 is equivalent to the sine of pi over 2 all over the cosine of pi over 2. So let's check it out. So at pi over 2 radians, which is up here, the sine value is the y coordinate, which is 1. And the cosine value, which is the x coordinate, is 0. And if you remember from earlier in the year, this is actually another review topic that we had done. 0 in the denominator is called undefined. So the final answer here is really undefined.